The way that we solve logarithmic equations is actually really, really similar to solving exponential equations. Isolate, convert, simplify, solve. Those are the exact same steps with exponential equations. So I have another procedure here, 1, 2, 3, 4, and I just kind of changed the words a little bit, but it's still isolate, convert, simplify, solve. Step 1 says isolate the logarithmic expression, and we might need to combine them into one log. And yeah, here, we can't get any logs by itself. I want a single log by itself. We're going to have to combine these two logarithms on the left-hand side. Well, we have a log being subtracted by another log. Which property did that have to do with? We have one log subtracting with another log. That's the quotient of their insides. So that's what we've got here. We can combine the left-hand side. It's the logarithm of the first thing divided by the second thing. This is exactly the same thing as what we started. We just used that difference property. So that was step 1. Step 2, convert it into an exponential equation. That's what we did in the very first video. Remember that the common logarithm is the same as log base 10? You want to write log base 10 if that helps you, go ahead and do it. To convert this to an exponential equation, base of the logarithm is the base of our exponential function. The input of the logarithm will become the output of our exponential equation. So that's going to go over here, 50x plus 25 over x. And the output of the logarithm is going to become the input of the exponential. This becomes a 10 squared. Now we can solve this equation, which looks a little weird. This is called a rational equation. We haven't talked about this too much. This is not really something I would expect you to solve. A little bit more complicated. But just like anything with a fraction, if we want to get rid of a fraction, we can multiply both sides of this equation by the denominator. The left-hand side's not too bad. X times 100. We can write that as 100x. And the right-hand side's kind of nice because we have an x in the denominator and an x in the numerator. Those cancel. The right-hand side is just 50x plus 25. And now it's an equation that I would expect all of you to be able to solve. So we converted it to an exponential equation. Now we're simplifying and solving kind of all at once. We need the x's by itself, so we're going to subtract a 50x from both sides. Now the left-hand side had 100. It lost 50. We have 50 x's left. Right-hand side is just 25. We're really close. Divide both sides by 50. We're going to get x is 25 over 50. That's just 1/2. There we go. That's our answer. Make sure you check your work, especially for these equations. All right? It's also good practice. We have the logarithm of 50 times x. What's half of 50? 25. Plus 25 minus the logarithm of x, which is 1/2. We're hoping that this simplifies down to 2. Well, this is the logarithm of 50, 25 plus 25, minus the logarithm of 1/2. And if you subtract two logarithms, that's dividing their insides. So 50 divided by 1/2, dividing by 1/2 is the same as multiplying by 2. This is the log of 100. Just like before, the common log of 100 is 2, exactly what we wanted. We wanted that left-hand side to equal 2. We looked at the left-hand side and we showed it equal 2. So it's really good practice and it's a good way of checking our work and making sure that we're right. Let's do this with b. I'm going to show you another reason why it's important to check your answer. So we need the logarithms by themselves. Right now there's a logarithm on the left and a logarithm on the right. Let's get them over to the same side. Let's subtract both sides by the log of x plus 2. Now we can't combine the left-hand side in a normal way. We have the logarithm of something minus the logarithm of something else, but we will be using that difference property on that left-hand side. The right-hand side is just a 1. The left-hand side combines with that difference property, x squared minus 4 divided by x plus 2. The right-hand side is still 1. So we've now isolated the logarithmic expression. We'll convert it to an exponential equation. This is the common log base 10. Base of the logarithm, base of the exponential. Input of the logarithm is the output of the exponential. And output of the logarithm is the input of the exponential. And again, just like before, to solve this, we multiply both sides by the denominator. Now we have 10 times x plus 2. Worry more about that later. And on the right, they cancel. We have x squared minus 4. This is a polynomial. This is a quadratic. How do we solve quadratic equations? We got to get everything onto the same side and either factor or use a quadratic formula. So before we can get everything to the same side, let's distribute. 10x plus 20. The right-hand side, x squared minus 4. Let's get it all over to the same side. Subtract a 10x, subtract a 20. Subtract a 10x, subtract a 20. And what that'll give us, the left-hand side is now 0. The right-hand side had an x squared. We subtracted a 10x. Those aren't like terms. We can't combine them. But we had a minus 4, and we subtracted a 20. So we'll subtract that minus 24. Now we can either use a quadratic formula, or we can factor. Factoring is usually best if we can. Let's try to factor. We need two numbers that multiply to that last term that add to the middle coefficient. So think about some numbers. You'd be able to get negative 12 and positive 2. That's how it factors. X minus 12. X plus 2. Let's do a quick check in our heads. X squared plus 2x minus 12x is minus a 10x. That's good. Minus 24. Good. It does FOIL to be what we want it to be. So when is this true? This is true when the first piece equals 0. That's when x is 12. And it's true when the second piece is equal to 0. That's when x is minus 2. These should be our answers. Let's check them. You could check them with a calculator or by hand like we did before. Okay. So with a calculator, we get the log of x squared minus 4. And x was 12, right? Log of x squared minus 4. Is that equal to the right-hand side? 1 plus the log of x plus 2. Yeah, left-hand side equals the right-hand side. That's great. What about the other answer? This one checks out. The other one's negative 2. So the log of negative 2 squared uh-oh. What about what? Uh-oh. Undefined equals undefined? Not good. You really do need to check your answers because sometimes the answers that would make this part true don't make the original problem true. So sometimes we get imposters. Okay? I wish I had that sound effect from... I'm too old. I don't remember the game. The game with the people and you find out who the imposter is. Gosh, I can't even think of the name. You know what game I'm talking about, right? Anyway, you can play it online with your friends. You're like trying to sabotage the ship. Anyway, let's move on. So sometimes when you're doing these, you're going to have imposters. You're going to have to check your answers. Okay. You have to check your answers. Make sure that nothing slips through on these log equations. All right. And it's a good habit to check your answers anyway. Because again, part of the method is that -2 is essentially not in the domain. We know the domain of these logs. The domain is when the inside is greater than 0. And when x is -2, the inside is equal to 0, which is not part of the domain of a logarithm. That's how it all kind of ties together. Anyway, that's it for this section. No homework video because there's so many examples in these videos, I think. But you can always ask me, send me a message, or come to student hours or something like that. Talk to me before, after class, whatever, and ask questions about this. So let me know if you have any questions, and have a good rest of your day. Bye-bye.